Hello everyone, my name is Nikita and I'm from the Bodhi Academy. In the last video, we were doing the chapter number 9 from 9th standard science textbook, that is force and laws of motion, and we have completed the first law and second law of motion and also numericals on it. Today we are going to do the last part of the chapter, that is the third law of the motion. Okay, so let us see today what is the third law of motion. Now, till now we have seen the first and the second law of motion, and both the laws say that the force is required to bring the object in motion. Okay, a particular force is required to change the velocity of a particular object and to change the direction of motion. Now we are going to see the third law of motion. Okay, now the first two laws of motion tells us how an applied force changes the motion and provides us with a method of determining the force. The third law of motion states that, okay, the third law states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first object. Okay, now what does this mean? If a particular object is exerting a particular force on the second object, this is object 1, this is object 2. Okay, if it is exerting a force F1 on other object, now the second object exerts an equal and opposite force F1 on the first objects. Okay, so if the first object exerts a force F1 on the second object, then the second object also exerts an equal and opposite force on the first object. This is the Newton's third law of motion. Okay, these two forces are always equal in magnitude. Okay, they are always equal in magnitude, means same amount, but they are opposite in direction. They cannot be in same direction because there are two different objects. These forces act on different objects and never on the same object. Okay, this statement means that this force will be exerted on the other object and this force will be exerted on the other object. It can't be like the force exerted by this object will be on the same object. No, it is not like that. Okay, so we understand that force exerted by one object on other object which exerts the same amount of force okay, opposite in direction. It is opposite in direction. Secondly, it is never on the same object. It is on the different objects. Okay, for example, in the game of football, sometimes while looking at the football and trying to kick it with a greater force, collide with a player of the opposite team. Both feel hurt because each applies a force to the other. Okay, in other words, there is a pair of forces. So over here, this law always works in a pair of forces. Okay, it always works in a pair of forces. It is not just one force, but it will always work in a pair of forces. If there is only one force exerted and this cannot exert back on the other, that means it is not following the third law of motion. For third law of motion, it always acts in a pair of forces. Okay, now there is one example over here to understand the third law of motion. Let us consider two spring balances connected together. Okay, now there are two spring balances over here, spring balance A and B, they are connected together. Okay. Now the fixed end of the balance B is attached with a rigid support like wall. Okay, so balance B, the fixed end, this is the fixed end. Okay, it is connected to the rigid support like wall, and the free end is connected to the balance A, spring balance A. Okay, when force is applied through the free end of spring balance A, it is observed that both the spring balances show the same readings on their scales. Okay, so when a force is applied on this side, on this spring balance, it is actually given to only one spring balance, right? But readings on the balance is both the balance are the same. Now why is it so? It means that force exerted by spring balance A on spring balance B is equal but opposite in direction to the force exerted by balance B on A. Okay, so force exerted over here, once a force is applied from this side, it exerts a force on spring balance B. Then once it gets the force, again spring balance B exerts a force on this. So this is equal forces, okay, but they are opposite in direction. That's why they show the same reading. Any of these two forces can be called as a action and the other one as reaction. Okay, so we can say that this has a action on this spring balance. To this action, the spring balance B gives a opposite reaction. Okay, so we can say that this gets us to another alternative statement of third law of motion, which is to every action there is an equal and opposite reaction. Means force exerted by first object, okay, on the other object is reacted back by the second object by exerting an equal and opposite force. This means that it is reacting to the force exerted by the first object. So there is an equal and opposite reaction to the particular action. Okay, so it acts on two different objects and not the same object. Okay, now there is a famous example over here. Okay, yeah, it is important to know that even though the action and reaction forces are equal in magnitude, okay, they are equal, the amount is equal, these forces may not produce accelerations of equal magnitude. They are equal in magnitude. Okay, the forces are equal in magnitude, F1 is equals to F1, okay, but they are opposite in direction. Magnitude, but the acceleration produced, we know that force changes the velocity of the object and gets the object into motion, producing acceleration, change in velocity. The acceleration produced will be different. Okay, it will differ. Why it will differ? Because it depends on the mass, right? How big the object is. Okay, this is because the force objects on different masses, objects of different masses which have different masses. So maybe a a larger mass object will, less force will be exerted to it. Even if the same amount of force is exerted to it, it will not produce that much acceleration because a larger force is required. Okay, so in this case acceleration will differ because of mass. Larger mass will give less acceleration with the same force. Okay, and lesser mass object will give more acceleration with the same force. Okay, so from this we can see this example. When a gun is fired, okay, when a gun is fired, a bullet, okay, it exerts a force on the bullet, it exerts a forward force on the bullet. Means forward force, the bullet goes outside, right? This is the forward force. So on the bullet exerts, so this is the forward force. Similarly, the bullet follows the third law of motion and exerts an equal and opposite force on the gun. Okay, so bullet is exerting a opposite force on the gun which causes the gun to recoil, which causes the recoil of the gun. Since the gun has a much greater mass than the bullet, the acceleration, now both have force, right? The bullet also has a force and it exerts an opposite force on the gun, which causes the recoil of the gun. But both have different acceleration, right? Both have different acceleration. Which one has a higher acceleration because of the force? The bullet has a higher acceleration. Okay, bullet has a higher acceleration, because of which it goes with a very high speed and hits the object. Okay, the acceleration of the gun is much less than the bullet. So acceleration of the gun is less, but that of the bullet is more. Okay, but both forces are applied, equal and opposite forces are applied, but depending upon the mass of the object, the acceleration differs. Okay, so this is the third law of motion. The statement is, you can even say that object 1 exerts a force on the object 2 and object 2 exerts a backward force on the object 1. So both the forces are acting in pairs. They are equal in magnitude but opposite in direction. So we can also say that every action has a equal and opposite reaction. Okay, and it always exists in the pair of forces. So this was about the third law of motion, and this is it in the chapter force and laws of the motion. In this chapter we saw the different concepts. First of all, we saw what is the mass, inertia, okay, then friction, then we saw the first law of motion, then we saw second law of motion, and from there we found out what is force, and today we saw the third law of motion. Very important in this chapter is the definition of all these laws, definition of mass, inertia, force, and the numericals, which we have done in the last video. Okay, so yes, thank you for watching my video. Please like, share and subscribe to our channel.